In our last video we stopped where we talked about color coding your nodes and color coding a node starting at one point and at one element and moving all the way, filling in the color to the next element. Now let's actually use that. So here's a circuit diagram. We show a battery, an ammeter connected to a resistor so that we can measure the current. We might want to measure the current in this circuit, and here's the voltmeter measuring the voltage across that battery. That's a picture of what the circuit would look like if we built it, but down here is the circuit representation. I'm going to show you how to color code the nodes. So let's start with the red node going from here all the way through our ammeter and over to our resistor. I want to make a note that if you are using ammeters and voltmeters in your circuit, basically ignore them. You draw your line through the ammeter and you ignore or just kind of remove the voltmeter. So there's one node. Here is another node. Okay, now there's an important feature of these nodes. The voltage along the black is the same every place on that node, and the voltage on the red is the same every place on this node. That's how nodes work. Now let's use that idea to define things that are in series and parallel. When I fill in my node like this, there is one part of my battery node. Here is another node. And here is one more node. Are those nodes ordinary or extraordinary? They're all in ordinary because they only have 2 wires and not 3. So let's see how we can tell when something is in series. If 2 elements share one color, such as these two, they are in series. So bulb number 1 is in series with bulb number 2. How about bulb number 2 in the battery? It shares only this black line, so bulb number 2 is in series with the battery. How about bulb number 1 in the battery? Well, they only share one color, so the battery and this bulb are also in series. In fact, all of the elements in this circuit are in series. Now let's look at a contrasting circuit. This is the parallel circuit. So fill in our node, color coding it like so. All that voltage is the same. Let's fill this one in, color coding it. Alright, we have 2 extraordinary nodes, a red one and a black one, in this circuit. Now if we want to know if something is in parallel, any 2 elements that share the same color, such as red and black, are in parallel. Well, this bulb is red and black, and this one is red and black, so they are in parallel. This bulb and the battery are both red and black, so they are also in parallel. All the elements in this circuit are in parallel compared to the other one, where they were all in series. Now, in a series circuit, the current is the same throughout the circuit. So the current comes out of the battery, goes through both bulbs, and comes back, and the current is the same everywhere there. Even if these bulbs are resistive, the current is not used up in them. The current moves through it and comes out, and it's the same current the whole way. Remember that we color-coded these. Here's the path for the current. It's moving along through the red node, and then it goes through the bulb, into the blue node, through the next bulb, and finally into the black node. And we could tell that this circuit was in series by noting that there was only one color between any of these elements, and lo and behold, the current is the same throughout this circuit. Now in a parallel circuit, the voltage is the same throughout the circuit. So remember this red node, we said that voltage was the same every place on the red, and the voltage is the same every place on the black. And we said that if 2 elements shared the same 2 colors, they were in parallel. Red, black, red, black, red, black. This is a parallel circuit. Now the voltage is the same. What does that mean? That means that if I hooked up my voltmeter right here, and I connected my red lead right here, and I connected my black lead right there. Oops, I need my black lead. Come on. I would measure the same voltage from red to black here as I would from here and from here. So the voltage is the same every place in a parallel circuit. Now let's take a look at several of these circuits and decide what's in series and parallel. This circuit right here, how many nodes does it have? It has one ordinary node. It has another ordinary node. That's 2 ordinary nodes. Here's a third ordinary node, 4 ordinary nodes, and finally 5 ordinary nodes. All right, let's see what's in series and parallel. If two elements share one color, they are in series. So the battery is in series with the first resistor. The first resistor shares only one color with the second, that's blue, so R1 and R2 are in series. So we can say R1 is in series with R2. Well, R2 and R3 only share brown, they're also in series, and R3 and R4 share only green, they are in series, and finally back to the battery. So R1 is in series with R2, which is in series with R3, and in series with R4. This is a series circuit, and the current is constant throughout. Now let's go over to our next circuit. Out of the battery, I'm going to fill in all of the node until I get to all the elements. So there is my red node. That's clearly an extraordinary node. Let's fill in this. Okay, there's a blue extraordinary node. That's 2 extraordinary nodes. And finally, here is the third extraordinary node. Okay, elements are in parallel if they share the same two colors, such as red to blue and red to blue. R1 is in parallel with R2. Similarly, blue to black, R3 is in parallel with R4. Okay, now how about this combination, which was R1 in parallel with R2, and this combination, which was R3 in parallel with R4. Well, if I looked at this combination, I would say that they shared a single color, this blue right here. They are in series. So I can say the parallel combination of R1 and R2 is in series with the parallel combination of R3 and R4. Now let's look at this more complicated circuit. Right here, is that an ordinary node or an extraordinary node? It's ordinary. This one right here, ordinary or extraordinary? It's extraordinary. There are more than 2 wires coming out of this node. And right here, how about this one? That's an ordinary node. There is another extraordinary node. That's an extraordinary node. And finally, here's one more. There's yet another extraordinary node. Okay, let's see what's in series and parallel. Here are 2 resistors that share one color, so I can see that R2 is in series with R3. Right here, I have 2 resistors that share 2 colors, so they're blue to yellow, so I can see that R4 is in parallel with R5. Let's go right here, R2 plus R3. All right, now let's start putting these in combinations. So there's the parallel combination of R4 and R5. Here's the series combination of R2 and R3. Well, I can see that the parallel combination of R4 and R5 is in series with R6 because it shares only one color, yellow. And I can see that this combination that I just described is in parallel with the series combination of R2 and R3 because they share blue and brown. So this combination is in parallel with this series combination of R2 and R3. And finally, that whole combo is in series or parallel with R1. It's in series because they share only one color, blue. This is what we'll be doing with throughout our circuits. We'll practice it some today, and we'll continue to practice it throughout the next couple of weeks. Here's a Wheatstone bridge. Let's decide what's in series and parallel here. The way a Wheatstone bridge works is that we have an unknown resistance, typically a sensor right here. Maybe it's a thermistor that changes with temperature, and we'd like to know what its resistance is. The way we can do that is we can take this variable resistor and we can change its resistance. We can actually dial the resistance or tune it until this voltage right here is equal to 0. Then we know that the variable resistor is equal to the unknown resistor. Okay, let's decide what's in series and parallel in a Wheatstone bridge. Here is one node, right there, and here is a second node, right there. What do I do about the voltmeter? Remember, the voltmeter I just remove. Just take it out of there. It's as if it didn't exist in this circuit. Why doesn't it exist? It's because the impedance of a voltmeter, or the resistance of a voltmeter, is really high. It's as if it was an open circuit, so we treat it that way. Okay, there's another node right there. And finally, here's one last node right there. Okay, so what do I have? I have two extraordinary nodes, a red one and a black one, and I have two ordinary nodes, a blue one and a brown one. Now let's see what we have for our circuit. Here I have two resistors that share only one color. R1 is in series with R2. Here are two other resistors that share one color. RV is in series with R unknown. And if I considered these one group and these a different group, then I can see there are my two groups. I can see that this series combination of R1 and R2 is in parallel, because they share red and black, with the series combination of RV and RU. So here is my set of resistors. Now let's talk about series and parallel battery charging and the application of the idea of series and parallel.